Now, the next presentation and another interesting topic out there, virtualization and OpenStack. It's quite popular and present everywhere these days. We have Ruben coming from Portugal, IT Center, another supporter of the starting also with the first edition. They have also exhibition spot if you need more information, and I'm sure everyone is interested in scalability and especially virtualization with OpenStack. They will be ready for you and answer some questions. Ruben, thank you for coming and helping with the event.
Thank you, Daniel. Hello, everyone. Just a quick intro to myself and the company. I'm the CTO and co-founder of IT Center. Been working with Asterisk and generally VoIP solutions since 2004, and also Kamailio. It was still OpenStack since 2008. So I also like wine and other stuff. So. IT Center was founded in 2003 in Portugal. We work only with open source technologies, and we have two main expertises, that is VoIP and virtualization solutions. Okay? We won in 2010 the award for DG Innovation Award, VoIP Today, and also Kamailio awards in 2011 for working a big project that we've done in the Portuguese universities, that we interconnected all of them using SIP and Kamailio and Asterisk. Also, we are considered from 2012 one of the best companies to work in Portugal. Okay. So let's talk about the customer challenge. So we had a customer that had these requirements: full feature VoIP solution, open standards, low bandwidth consumption, scalable, resilient, distributed, and no single point of failure. Okay? We sit down and talk about what was the solution. Okay? Our first three topics was fairly easy to find. Kamailio, free switch, and peer-to-peer media. We are not focusing on this. We are focusing on the next part. Okay, that is, how do we build a scalable, resilient, distributed, and no single point of failure solution? Okay, so our expertise was based on this. That is, using OpenStack and buckets. Okay. Cloud deployment and orchestration together. It's the way that we found to build a really scalable and distributed solution. So what's OpenStack? OpenStack is open source cloud operating system. Everyone, I believe, has heard something about this. It's a very powerful modular system that you can build like a gigantic cloud, and it can be distributed all around the world or in a private data center or whatever you want. Okay? It controls compute, storage, and networking like devices. Then as a dashboard, as APIs, and it runs over standard hardware, of course. So who's using OpenStack? We, IT Center, most important. Then, for example, PayPal, they migrated all their existing VMware to PayPal, to OpenStack, sorry. Cisco WebEx, CERN is a big supporter of OpenStack. MIT NSA is using OpenStack. I don't know if it's good or it's bad, but they are using it. So also the big players in the IT industry like Intel, IBM, Sousa, HP, Dell, and one of the biggest also cloud provider did this Rackspace. Okay. What is the OpenStack mission? This is from OpenStack official documentation. It says that it's to provide scalable, elastic cloud computing for both public and private clouds, and it must be simple to implement and massively scalable. So this is the big point. Okay. What is our mission? Let's just show it to you. It is just a second. Small video that we produced, if it opens. It's not opening the internet. Okay. Let's hope that the internet here access.
Yeah, Ruben, you qualify for a dangerous demo.
Yes.
If you just downloaded this.
We tested it.
Yeah, we tested it earlier, so probably it's the box guys that doesn't use OpenStack, yeah, so they are struggling to get. I don't know why. Maybe you can download it and see it after.
Yeah.
Yeah.
Let's see if it's opening.
No, it's just and then open. This is open. Ah, okay. So 3 seconds in German, I believe. No, it's not working. It should be like a. Okay. Ah, okay. So it opened. So our mission is auto-scaling without human intervention. This is the name of the solution. Auto-scaling without human intervention. It's our mission. So imagine that you are you have your users that are just calling each other, and then your machine is like green, and then when starts to have more users, millions, thousands, you have a lot of problems in your resources. The guy, your IT manager gets distracted, talking to a nice girl, and we have the system OpenStack that is monitoring and creating new resources automatically without any intervention from the IT manager because it's distracted. Okay. Now we have Puppet that integrates and configures the system and puts it in the existing infrastructure. At the same time, because it's getting load balanced, the resources will get normal again. Okay. So this is our mission. We'll show it how we done this. Okay. So this is a quick look at the OpenStack Dashboard. It has all your machines, all your resources there, You can see the virtual CPUs, the RAM, the floating IPs, the number of machines, and so on. Okay, so you can do administration or provision or whatever from this dashboard. Then, what are the components that we use on OpenStack to provide the auto-scaling mechanism? First, we use it. It's the orchestration service. It uses a template mechanism that integrates with Puppet or Chef. Then it creates and deletes infrastructure resources. That means machines, network, whatever. And it integrates with Silometer. That is the the monitoring system that can check the resources of the machine. It can trigger, the Silometer can trigger it to create new instances based on predefined alarms or thresholds. For example, if you have a system that goes up the memory or the CPU or the network usage more than 50%, for example, it can trigger the alarm to it. Okay. Then we use Puppet that deploys configuration, also does patching management of this configuration, and integrates these new machines that are created and deleted, this new configuration, on the existing infrastructure. Okay, so you have to insert them on DNS records, database records, the SIP load balancers, and so on. Okay. So this is our overview of our normal workload architecture. We have DNS servers, then we have like load balancers that balances all the SIP traffic. We have our Kamailio call for processor that authenticates endpoints, SIP registrations, routing, presence, and so on. Then we have our media server, application server that is the free switch instance that does transcoding, voicemail, conference call queues, and so on. And we have a MySQL cluster that is the database of all the servers. Okay. Now we'll imagine that we have this need that is auto-scaling by stack. Possible scenario. Let's imagine this. Your biggest customer network goes down for some reason. Natural disasters, UFOs, NSA, who knows. Okay? And when it comes back again, you get flooded with SIP requests, registrations called routing, presence, BLFs, and even more that we don't imagine. The Kamailio, as strange as it seems, is struggling to process all the requests, and you get all the usage is rising and rising and rising, and you're pulling your air out. Okay, if you have air. So what is what happens next? Silometer checks that you have your threshold, for example, at 50%, gets an alarm, and sends and triggers it to create a new stack of Kamailio server that we call CCP3, for example. Puppet applies the configuration and adds this new CCP3 to the existing infrastructure, for example, the SIP load balancers. So when we get the call, he does the load balancing for the 3 servers instead of only 2, okay? For example. Then when he checks that the usage is normal again, all the phones registered, all your million user phones or something like that gets registered. He checks that the usage is below 50% again and triggers to delete. Okay, so you get free resources again. Okay? So it creates and deletes afterwards. You get normal usage, and Puppet removes that server from the existing infrastructure. Okay, this is by stack, so we can create DNS server, load balancer, call processor, media server, or database node by need, okay, by stack. Then we have by feature. Okay, in this case, we also have this case that we imagine that we have Kamailio sending for a pool of servers, and we have for all the features, but for the feature that you know that are more heavy load, like a call queues and call conference, you have a different pool of server, okay, a dedicated server. So let's imagine again, for some strange reason, all your customers book conference calls to the same day and hour, like the conference day or something like that. So you'll get, as I said, you'll have a Kamailio that divides the features by type. So it sends the call queues for MDS3 and conference calls to MDS4. And once again, because you get a lot of conference calls, it starts rising on that server. So as the same way as I've shown you, the silo meter check that only that machine is getting a lot of conference calls, and it creates a new machine with the configuration for a conference call server with a free switch and all the packets that it needs, applies the configuration to CCP and the server, of course, and it gets load balancing, and you get customer service working, and you can have quality in your conference calls, and you can have the number that you need. Okay, so
question. What's the usual time from when a trigger for a new machine and the new machine is available?
yeah, that's a very clever question. Normally, you get, depending on the packets, but you get, because it's a template image system that we put an image, like a CentOS or like basic Linux, and then we just install package and the configuration. It takes around 3 to 4 minutes, okay, to get the server working, okay, after the trigger. Okay. Depends. You can have more than one server. This is a simple example, but you have more than one server. You can have the threshold for usage for this amount of time. Okay, it's just not when it passes this 70%, but for 5 minutes or something, whatever you want to do. Okay, but it takes around 3 to 4 minutes, depends on where are the packets and what are the network conditions. But it's pretty quick. Then, the same way, when the system, when it's normal usage again, it will delete the conference call, the new conference call server, and you have free resources again to another strange customer feature by the end day, and you get normal workload again. Okay? So, autoscaling without human intervention, mission accomplished, because this guy is in Portugal in the beach, and it was the same guy on the video. So everything is working, and this is our way to do the autoscaling. Okay. So questions.
Okay, before the first question, I see a couple of questions here. Just to say that, okay, Ruben was a bit modest, but they run like over 300 instances of Kamailio and Asterisk on the entire Portugal academic network, universities, research institutes, so it's quite a big deployment out there. I'll take this one first, and then here first.
When you're spinning up and provisioning new instances, presumably you have to modify the configuration on existing instances so that they're aware of host names. How do you ensure that when you are modifying those existing configurations in automated fashion, you don't negatively affect the existing configurations so that you don't route traffic to host names that don't exist? How do you do sanity checks on the configuration changes you need to make to existing configurations?
What we do normally, because our system is working like everything is on the database, so we just insert records on an existing database. Even DNS is working with MySQL Server database, so it's pretty easy to us to insert or remove a record. We can do some sanity checks, but that is done on the Kamailio layer. Okay, so imagine that we are getting to try to send a call to one of the free switch servers that are not responding, and we just put that as like an offline server and send to the other. Of course, that you can even do something like this. That is, if one of the servers that is currently working and is not responding because some of strange problem of hardware, it also can create a new server and send a new request to that server. But normally, as replying to your answering your question, the sanity checks are done on the Kamailio side for the free switch, and the customer the DNS is more on the client side, like the user agent that tries to work with one of the DNS servers or something like that. So it's pretty basically the steps.
Okay. Other questions? Yeah. Okay.
What happens when your load gets too high in your database layer and you need to scale up your MySQL instances or your PostgreSQL instances or whatever? Is that as fast and easy to scale up, or is it more complicated to scale the database?
In the same way, we have MySQL cluster. I don't know if you are aware, but it has like a lot of data nodes, okay? And you can grow with more data nodes. And you go to the controller and say, I have a new data node, and in the controller, you add this configuration to the controller, okay? So you have this new data node, you put on the controller, and it has a new server. So it's pretty basically the same way that we do all the because you have to have like a standard basic servers that are the normal architecture, and then it grows by demand. If it's on the database layer, it will create database nodes. If it's so it's pretty basically the same way that we do this. Okay. We add to the controller MySQL server. Okay.
Is it NDB cluster you're using for MySQL?
Yeah. Exactly. NDB cluster. So we can integrate with Kamailio. Okay.
More questions? OpenStack scalability. Thank you, Ruben.
Thank you.